Communication protocols are a very important part of an instrumentation system. In general, communication protocols are a set of rules used to communicate between components of a system. In instrumentation, the same is true. A set of rules used to communicate between components of a system, including instrumentation, the controller, actuators, and the HMI, or the human-machine interface. So we can see here we have the level sensor, a human-machine interface, which is a screen that an operator can view the information being read by this sensor, the termination cabinet, and the engineering station. These are all components of the system. This is a current loop, or a 4 to 20 milliamp loop, and that is the type of communication protocol this instrumentation system is using. So the level sensor measures the level of the tank. Internally, it modifies the signal and sends a signal somewhere between 4 and 20 milliamps to the termination cabinet, which is read by the controller. The actual distance from the wire connected to the level sensor all the way to the termination cabinet is 1,000 feet. That's important with communication, and we'll see why in a moment. So now we'll look at a few different types of communication protocols that are used in industry. We have the 4 to 20 milliamp loop, which is good because it's resistant to EMI, or electromagnetic interference. It has a fast reaction. A downside that is each instrument requires its own set of wires, and it's very popular. Next we have the HART protocol. This runs on the infrastructure of the 4 to 20 milliamp loop, or the current loop. You can see here, when we look at current over time, the black curve is the 4 to 20 milliamp signal. On top of the black curve, we have an FSK, or the frequency shift keying. This is the HART signal, where the frequency is actually communicating to the controller. This allows us to communicate on the same infrastructure. We're using the same wires, but instead of just being able to communicate the information from one instrument, we can now communicate numerous sets of data over one set of lines. So say we have a plant where we're measuring with the level sensor like we just looked at. Now with HART, we can add a temperature sensor, for example, of the same tank. And this temperature sensor can communicate via HART, or FSK, over the 4 to 20 milliamp loop of the level sensor. This will greatly reduce that 1,000 feet of wire that we need. Now we only have to run the wire from the temperature sensor up to the level sensor wire, rather than running the wire all the way from the temperature sensor to the termination cabinet. This allows us to save a lot of wire and work. Next we have Modbus. This is a communication protocol that allows us to actually download our controller program into what we call a Modbus gateway. So the Modbus gateway will actually contain the program for controlling via the instrument. This allows us to decrease the wires that we need running from the instruments to the controller. So in this example, we have decreased our wire length from 1,000 feet, as we previously saw in the 4 to 20 milliamp or HART loops, to only 200 feet, as we are able to place a Modbus gateway about 200 feet away from all of these sensors. This will allow us to greatly decrease the amount of wire that we need, down to 200 feet times 2 wires and 4 sensors gives us only 800 feet of wire, as opposed to 8,000 that we needed in the previous example. Next, we'll talk about Foundation Fieldbus. This is the final communication protocol that we will examine in this video. Foundation Fieldbus is a lot like Modbus. The difference is that Foundation Fieldbus can actually provide power to the instrument through its communication line. It can utilize 2 different types of communication lines. One is the 2-wire pair, similar to all the instrumentation we've looked at so far. It can also use Ethernet. However, if Ethernet is used, we are not able to power the instrument via Ethernet yet. However, research is currently being done on this, so it may be available in the future. A further benefit of Foundation Fieldbus is that we're actually able to download the control program into the instrument itself. This means if something were to happen to another part of the control system, the instrument may still be able to operate. These are just 4 of the common types of communication protocols you might experience in industrial control systems. Some other communication protocols that we might not find in industry, but we might find in other instrumentational uses might include CAN, or Controller Area Network. This is the industry standard in automotive systems. J1939 is used in diesel applications. Ethernet is used in many types of applications and networks. GPIB, or General Purpose Interface Bus, is utilized in measurement equipment. So, for example, if you go into the lab and look at the back of the oscilloscope, you will very likely see a GPIB interface. And one we're most nearly all familiar with is USB, or Universal Serial Bus. So these are other types of communication protocols that we might find in instrumentation. So all of the communication protocols we've mentioned so far are all used in wired systems. Each communication protocol requires a specific hardware. For example, the transceiver, the wire itself, and the connectors used. Some of the protocols require different hardware, while some of them may utilize the same hardware. For example, the 4 to 20 milliamp loop and the HART. This is a good example that engineers came up with while utilizing a different protocol but the same structure. It's maximizing our use of our existing system. Finally, it is important to note what hardware you might need for a specific instrument. Certain hardware looks very similar while it may not behave the same. For example, the Modbus protocol uses a DB9 connector. This transceiver requires a 120 ohm resistor across its transmit and receive lines. Not all transceivers require this, but they might look the same. Some of them require diodes, some require different resistances across different pins. So just be aware of the hardware that you're using when you're interfacing with instruments. To sum up, we have looked at 4 different communication protocols. The 4 to 20 milliamp loop, which requires 2 wires and a single communication on each wire. The HART uses the same 2 wires from the 4 to 20 milliamp loop, but it allows us to connect numerous instrumentations on the same wires. The Modbus communication protocol, which requires 2 wires, but they're much shorter because of the Modbus gateway. Finally, we have the Foundation Fieldbus, which requires 2 wires. It can also provide power to the instrument.